Imagine ascending to a height of 100 meters to check a wind turbine, only to find a fracture that threatens to result in the complete shutdown of the machine. Isn't it terrifying? Wind turbine blades are subjected to a great deal of stress by virtue of the fact that they are exposed to wind, rain, dust, lightning, and years of operation. Even the smallest flaw might result in significant energy waste and expensive downtime for the organization. Cracks, delamination, lightning strikes, erosion, and inadequate repairs are the top 5 most common blade defects, and we will reveal them in today's video. We will also demonstrate how early detection of these defects with the assistance of WinLab may save millions of dollars. 1. Cracks. When it comes to flaws, cracks are among the most common and potentially hazardous mistakes that technicians face. They may provide the appearance of minute surface lines, or they may develop into significant structural breaches. Fatigue stress is caused by the continual rotation of blades. Environmental stress, which may be caused by high wind gusts or storms. These are the most prevalent causes of fractures. Impact damage, which may be caused by things like debris or bird attacks. Why they are significant? Cracks reduce the blade's ability to withstand stresses. If the fracture is neglected, it may quickly expand over the surface, causing the blade to break catastrophically. Even a hairline crack can cause widespread damage. A percentage of the cost of replacing a blade is spent on repairing a fracture at an earlier stage. A guide to identifying cracks. The first step is to do a visual check. It is important to examine the leading and trailing edges in great detail. To identify microcracks that are not apparent to the naked eye, use dye-penetrant testing or ultraviolet testing. Remember, the parts closest to the root and the tip experience the most stress. Benefits of using WinLab. Through the process of analyzing drone video in real time, WinLab is able to identify potentially problematic lines, markings, or shadows, and categorize them as either mild, moderate, or severe cracks to classify them. Because of this, technicians are able to prioritize essential repairs instantly without having to second-guess themselves. 2. Delamination. The delamination of the blade is yet another significant problem. Specifically, it takes place when the several composite layers that comprise a blade start to separate from one another. It's like peeling paint or a sticker that starts to lift. Once it starts, it spreads. Low bonding during the production process and high mechanical stress are 2 of the causes. Water gradually infiltrates the material. Why it is significant? In the process of delamination, the structural integrity of the blade is compromised. It has the potential to cause unexpected and unforeseen blade failure, in addition to reducing the aerodynamic efficiency of the blades. It is possible for significant pieces of the blade's surface to break off while it is being used in extreme circumstances. Identifying the signs of delamination. Perform a tap test on the device. It is an indication of separation if a part generates a hollow sound. Utilize thermal imaging techniques. There is a difference in the way that delaminated portions absorb and release heat compared to unbroken parts. Conduct a thorough assessment of any suspect areas during each and every scheduled inspection, particularly following storms. Benefits of using WinLab. Through the use of color-coded severity maps, WinLab is able to evaluate inspection photographs and identify areas of delamination. This allows for more intelligent repair planning by enabling specialists to differentiate between superficial separation and deeper, more serious delamination. 3. Lightning strikes. Blades, being the tallest component of a wind turbine, are vulnerable to lightning strikes. It is possible for lightning strikes to produce both obvious and concealed damage, even when lightning protection mechanisms are in place. Why they are significant? Lightning strikes produce temperatures that are more than 30,000 degrees Celsius, which may instantaneously cause the surface of the blade to explode, melt, or pierce. Although surface burns may seem relatively small, the true danger is inside the structure itself, namely in the form of broken fibers and resin layers that weaken the structural strength. Identifying lightning strikes is as follows. Ensure that the blade is inspected for any burn marks, scorch lines, or melted material along its length. It is important to look for any little openings that might potentially enable water to enter. You can use ultrasonography or thermography to detect concealed internal fiber damage. Benefits of using WinLab. To recognize lightning strike patterns in inspection film, WinLab's artificial intelligence has been taught. In addition to highlighting evident damage, it classifies hits as either minor, major, or critical via a classification system. This system guarantees that technicians concentrate on critical problems first, so averting incidents that might have devastating consequences. 4. Erosion. Erosion is a slow, progressive defect that wastes a lot of energy. The leading edge of blades is the primary area that is impacted by this phenomenon, since that is where particles of rain, hail, sand, or dust strike at high speeds. The following are some of the reasons why it is important. Erosion lowers aerodynamic performance. If erosion is not repaired, it may cause a loss in energy production of up to 5% per year. Severe erosion makes future repairs more costly, and it may even require complete replacement of the leading edge. You can identify erosion by visually inspecting the leading edge and the blade tip for signs of pitting, thinning, or scratches. In order to get a comprehensive perspective of surface wear, you need to use drone scans. Compare the current erosion with the data from previous inspections to track its progression. Benefits of using WinLab. WinLab monitors erosion trends by comparing historical pictures. Not only does it categorize the present degradation, but it also forecasts when the performance losses will become considerable, which enables operators to book preventative maintenance at the appropriate moment. 5. Poor repairs. On the other hand, not all damage to blades is caused by nature. Some of it is caused by errors made by humans. Inadequate fixes are a prevalent kind of fault, and they often make the previous problem much worse. The following are some examples of repairs that are not done properly. An example of an inadequate fix is using the incorrect resin or filler material. The uneven patchwork condition disrupts the blade's aerodynamics. The surface finishing or curing process takes too long to complete. Why they are significant? A poorly done repair will result in weak places. These sections often fail again when subjected to stress, which results in recurrent periods of downtime. When repairs are not done properly, the blade's lifetime is reduced over time, which in turn increases the expenses of operating. Identification of substandard repairs. Be on the lookout for surfaces that are uneven or colors that do not match. Ensure that the portions that have been fixed are free of bubbles, peeling, and recracking. The repair regions should be compared to the specifications provided by the manufacturer. Benefits of using WinLab. Using defect-free standards as a benchmark, WinLab is able to identify irregularities in regions that have been corrected. Technicians are provided with the assurance that the repair is dependable, or they are notified if a rework is required instead. Technician tips for spotting defects. The leading and trailing edges should always be inspected first since they are the most susceptible to damage. Visual inspections, drones, ultrasonography, and thermography are some of the inspection technologies that should be used. Take pictures or videos of each and every flaw and document them. WinLab is able to handle this data to do immediate categorization. Do not underestimate the significance of tiny flaws. The majority of catastrophic failures originate from problems that specialists initially considered insignificant. Why early detection matters. Catching these faults early is vital for safety and economics. Unchecked single flaws can render a turbine inoperable for many weeks. Downtime might put operators at risk of losing up to $30,000 each day. The early diagnosis and repair of a turbine may save millions of dollars over the course of its lifespan. Not only are professionals able to identify flaws more quickly with the use of cutting-edge equipment, such as WinLab, but they also lessen the likelihood of making mistakes. The result is increased production of renewable energy, decreased expenses, and safer operations. Like, share, and subscribe